Hey everyone, it's that math magician. On this video, we're going to take another look at similarity, and we want to see, can we prove that two triangles are similar using a flowchart. And we're given this example problem here where two triangles there are connected at point P, and we want to use a flowchart to prove that these two triangles are similar. So remember, we have three similarity conditions. We have side, 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 angle, angle, and side, angle, side. And looking at these two triangles, we want to hopefully eliminate some of the ones that don't work. Let's start off with side, side, side. In order for us to try to make a flowchart for side, 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 we have to know three sides. I'm looking at these two triangles up here, and I only see two known sides. And there's no way for us to find that third missing side. So because of that, side, side, side is not going to work here. So then you might be thinking angle, angle, because angle, angle is the easy one. Angle, angle only requires two bubbles, two facts on our flowcharts. So maybe that will be the one that we want to use. But I'm looking at these two triangles, and again, I don't really see any angles marked. I don't know if any angles are equal to each other. And so for that reason, I really don't want to go down the route of angle, angle, because I just don't have enough information for that. So that leaves us with side, angle, side. And side, angle, side might work here because for side, angle, side, I need to know two sides. And I'm looking at these two triangles and I have two known sides. So let's start off that process, and then maybe along the way we'll find an angle matching with another angle on those triangles. So let's go ahead and start off with our flowchart here. We want to start comparing sides and looking at zoom factors. I'm going to go ahead and start off with the side 15 and the side 10. And to compare those two sides, what we want to do is we want to make a fraction of those sides, showing the zoom factor. So I'm going to go ahead and write out 15 divided by 10. Doing this will allow me to see my zoom factor, and 15 divided by 10 ends up equaling 1.5. So I see right off the bat that the zoom factor for those two sides going from 10 to 15 is 1.5. So now let's go ahead and check out another set of sides that we have, which is 8 and 12. So again, let's see if they have a matching zoom factor. Well, to do that, I'll have to take 12 and I'll have to divide it by 8. And what's 12 divided by 8? You punch that into your calculator, and we see that it ends up equaling 1.5 as well. So far, so good. We have two sets of sides with the same zoom factor. This is good for us. The only other thing we need to prove side, angle, side is an angle that matches in both triangles. And at the moment, like I said, there are no angles up here that match. But I want to draw your attention to point P. Remember, point P right there is where those two triangles are meeting. And where those two triangles meet, we end up creating these two angles here. And those have a special name. Remember, two intersecting lines, they create vertical angles. And vertical angles is an angle relationship that we can't forget about because it's showing up right there. And vertical angles means that this left angle and this right angle are equal. So now we can go ahead and say with certainty that those two angles equal each other. That's our third fact. That's all we need to prove that these are similar. So let's go ahead and write it. What we can't write is we can't write that the measure of angle P equals the measure of angle P because of the fact that there are two angles at P, and I don't know what angle you're actually talking about. So instead of writing it this way, what we need to say is we need to trace out the angles to get three letters to name that angle. We'll start with the one on the left. We'll call this angle NPM. NPM. That's what we're going to call this guy. So the measure of angle NPM equals the measure of angle, we'll name this guy now, QPR. Just trace the angle out, get your three letters, QPR. And that is our final fact for our flowchart. We can say with absolute certainty now that these triangles are similar. So we'll say triangle NPM is similar to triangle QPR. How did we find that out? Well, we used side, angle, side similarity. That is a complete flowchart proving that those two triangles are similar because two sets of sides have an equal zoom factor and the angle in the middle are equal. It's that Math Magician, and I'll see you on the next video.